Alright, so here we're going to look at fractional exponents and what they mean. So first of all, let's start with just evaluating some of these. We can straight up use a calculator for now. So 4 to the 1/2, you can punch in for exponent 1 divided by 2. That will give you 2. 9 to the exponent 1/2 gives you 3. 25 exponent 1/2 gives you 5. So hopefully you might see a little bit of a pattern here. You might notice that this number is just the square root of this number. And this number is just the square root of this one. So this is equal to the square root of 4. This is equal to the square root of 9. This is equal to the square root of 25. Okay? So I can see then that if I have an exponent of 1 over 2, it's just my square root. If I continue the process but using exponent 1 over 3, I can see that 8 exponent 1 over 3 gives me 2. 27 exponent 1 over 3 gives me 3. And 64 exponent 1 over 3 gives me 4. And you may recognize that 2 is really just the cubed root of 8. 3 is just the cubed root of 27, and 4 is just the cubed root of 64. So what you notice here is that whatever the denominator is in the fraction ends up being the index of the root. Because of course when a radical doesn't show the root sign here, the index here, we assume that it's a 2, that's a square root. And this denominator being a 3 makes this a cubed root. So you could continue then and say that, all right, well, something like 16 to the 1 over 4 must be the 4th root of 16, and you'd be completely correct. So in general, anytime you have anything raised to an exponent of 1 over n, whatever this denominator is here, ends up becoming the index of the radical. So if I've got exponent 1 over 5, this becomes 5th root of whatever the number is. Okay? But of course, when you have fractional exponents like this, you don't always have to have 1 in your numerator, like all of these had 1 in the numerator. Sometimes your numerator could be a number that's other than 1. So let's look at how we can handle that. So let's say if I have 9 to the 3 over 2. So if I've got 9 to the 3 over 2, let's just step over here for a second. 3 over 2 is a single fraction that I can actually split apart into 2 fractions multiplied together. Because I can say that 3 over 2 is the same as 3 over 1. Actually, I'm going to change that. I'm going to put the other one first. It's the same as 1 over 2 times 3 over 1. Okay? Because if I were to multiply these 2 fractions together, I end up getting 3 over 2. 1 times 3 is 3, 2 times 1 is 2. How can I use that property? Well, I can say that instead of leaving this as 9 to the 3 over 2 here, I can split it apart and write it like this. I can say that 9 to the 3 over 2 is the same as 9 to the 1/2 raised to the exponent 3. And the reason that I can do that is because when I multiply these 2 exponents together using the exponent laws, when I multiply these 2 exponents together, 1 times 3 gives me 3, 2 times 1 gives me 2. So based on that, I know that this is equivalent to this right here. Okay? So looking at what's inside here, since this is a 1 over 2, I know that this is really just the square root of 9 inside. So I could rewrite this as the square root of 9 cubed. Okay? So what you may notice here, so this means that the index is 2 and the exponent out here is 3. So you can see that from the original, my 9 went inside the radical, it became the radicand. My denominator became my index, and my numerator ended up being the exponent out on the side. And it doesn't matter what numbers you have here, this pattern will always happen. So whatever's here will end up going there. Whatever the denominator is becomes the index, and whatever the numerator is becomes the exponent. So in general, if I, instead of having a to the 1 over m, if I have a to the m over n, then I know that the n becomes my index, so I have the nth root of a, and then the m becomes my exponent, so it all becomes raised to the exponent m. Okay? So, where do I? So in that case, when I have something that looks like this, so x to the 2 over 3, for example, I can always take that and turn it into the radical form, because I know that my denominator here always ends up becoming my index. So this is going to become the cubed root. Of course, this is the subject of my exponent, so this is what goes underneath into the radicand, and then the numerator here ends up being my exponent. Okay? If we reverse that, let's say if I give you something that looks like this, then you could now take that and turn it into a fractional exponent. So this is the radicand, which becomes the subject of the exponent, or the power. This is the index, which ends up being my denominator. This is the exponent, which ends up being my numerator. Alright, so you should be able to convert between these two forms without too much issue. So now, how can we use that? Well, we can use that to evaluate expressions that look pretty ugly, but actually end up not being all that bad at all. So if I have 27 to the 4 over 3, I know that the denominator here becomes my index, so this is the cubed root of 27, and it gets raised to the exponent of 4. Cubed root of 27, well, 3 times 3 times 3 is 27, so that means that this becomes 3 to the 4. And to find 3 to the 4, well, if you don't know what 3 to the 4 is off the top of your head, you can always square twice. So 3 to the 4 is actually the same as 3 squared, and then square it. So 3 squared is 9, square again is 81. So 3 to the 4 is 81. Of course, the numbers don't always look that nice. Sometimes they're a little bit uglier. So one of the examples that your textbook shows looks like this. And a lot of people prefer working with decimals, but they actually make things more complicated, especially in this case here. So what I'm going to do is take that decimal and write it as a fraction first. So how to write decimals as fractions? Well, what you should realize is that this is the decimal point, so this is the 10th place, and this is the 100th place. So this means that I've got 4 hundredths. So if I've got 4 hundredths, then that means that it can be written as 4 over 100. So I'll rewrite this as 4 over 100 to the 3 over 2. And now what I'm going to do, since there's a bracket around this right here, I'm going to apply this exponent to each piece that's inside this bracket. So I'll write this as 4 to the 3 over 2 over 100 to the 3 over 2. Alright, so now let's evaluate 4 to the 3 over 2. Write that as a radical. So 4 to the 3 over 2, my denominator is 2, that makes this a square root of 4. Numerator is 3, so I'm going to cube that. Evaluate my denominator here, so 100 to the 3 over 2 is going to be the square root of 100, and then I cube that. So the square root of 4 is 2, so this becomes 2 cubed. Square root of 100 is 10, so this becomes 10 cubed. So my answer then becomes 2 cubed, which is 8, over 10 cubed, which is 1,000. And I guess technically you should reduce this fraction down. So I believe that would give you 1 over 125. All right, so let's look at one more example before ending this video. So let's look at something that starts out as a fraction. So 9 over 49 to the 3 over 2. So you might notice this looks somewhat similar to what we just did. Let's just do another example. So what I'm going to do is apply this exponent to both terms that are inside the bracket. So this is going to be 9 to the 3 over 2 over 49 to the 3 over 2. 9 to the 3 over 2 is going to be the square root of 9 cubed. 49 to the 3 over 2 is going to be the square root of 49 cubed. Square root of 9 is 2, so this becomes 2 cubed. Square root of 9 is 3, so this becomes 3 cubed. Square root of 49 is 7, so this becomes 7 cubed. So I just evaluate 3 cubed, which is 27, over 7 cubed, which is 343. All right, and that covers fractional exponents.